Hello and welcome to Exercise 1 of SPARC's Introduction to Digital Archaeological Reconstructions. So this is essentially covering parts of B and C of Exercise 1, where you use CloudCompare to prepare, clean, and mesh your laser scan dataset from Malthi for use in your digital reconstructions in later exercises. So to open the files from the laser scan data sets, we'll start with these guys here, these LAS files. And so you can see that these are quite large, so you'll probably only be able to open one or two at a time, but for now we'll focus on just slice one. So essentially this tells the software what sort of information to look for in your LAS file as it opens it, but essentially the defaults are all fine. So go ahead and hit apply. So this pop-up window is where you have to make a few decisions. So these, as you can see, it says these coordinates are too big. So these numbers here are the laser scan has actually preserved the site's global position using the universal transverse Mercator coordinates. So the numbers we're looking at here indicate the site's distance from the equator and prime meridian in meters. And so this is quite a large set of numbers here. And so while this is fine for things like GIS systems, ArcGIS, things like that, these numbers are much too big for 3D modeling software that we're going to be using later on in other exercises. So if you keep these can cause graphical glitches, all sorts of other things can happen. So the best thing to do here is to uncheck preserve global shift on save, otherwise it will keep everything in these very large numbers. You'll want to take note of these numbers here so that you can copy and paste them into this pop-up when it comes up again for slices 2 through 8. And so make sure you jot this down either on paper or in a word processor. And then click yes. And then it'll take a while to open all 121 million points. So once it finally loads, you'll have all sorts of little notifications in the console at the bottom here, and so some of these it shouldn't be a big problem. Mostly it'll say, oh, we didn't find this data in the file. Basically, as you can see, they didn't the laser scan did not record color, and so that's all there just in case you were expecting something that didn't show up, but this is all fine for us. And so you can see that this is profile slice 1 that has appeared in our space here, but it's all white points. So the easiest way to get everything visible and looking more like a three-dimensional point cloud is to play with some of the display functions. So one that is quite useful here is under display shaders and filters, EDL shader. And so you can see we can actually see some of the three-dimensional aspects of this laser scan data here. If you want to add a bit of color to this as well to get sort of essentially a height map where the highest points are red and the lowest points are blue, we will ensure that our cloud is selected. Go to Edit, Scalar Fields, and export coordinates to SFs. And so the one that we want to export is the Z coordinates, because in this software, Z is your essentially up and down values, your height values. So this will change in other software, but for now, that is what we will use. And so we'll hit OK. So as you can see, this has essentially mapped color to individual points based on its change in elevation overall. So the highest points are red, the lowest points are blue. And as you can see, my computer is having a hard time keeping up because there are quite so many points. So something that you'll need to do will be to slice this into more manageable bits. So what we're going to do is we're going to use the segment tool here. And so you can see I've turned segmentation on. It warns you ahead of time. And so what you'll do, it tells you to left click, add contour points. So as you essentially draw a polygon around the sort of subsection of the slice you want to create, now make sure you keep note of what sort of features you might be cutting through, because when we mesh things, this does affect the results of the mesh. So if I aim for like right through the middle of a structure, it may end up looking a bit weird when we're putting these features together. So you kind of want to aim for between walls if you can. And then you right click with your mouse to close. And so you can see it's not following my mouse anymore. And so we want to segment in. And so this is the segment that we are left with. So if you're happy with that, you can hit the little green check mark. And so you can see that it has segmented our point cloud here. So that now these guys are separate. So you might want to save these guys over here for later segmentation, because we will still want these parts of the site, but for now we'll just turn those off so that everything runs a bit smoother. So you can see that if we go down into the properties window for this bit of the segment, you can see that we're still working with 53 million points, and that's still quite a lot. So another thing you'll want to do is to subsample your point cloud. So that was essentially part B in CloudCompare and step 1 of part C. And so now we're going to move on to step 2 of part C, where we're talking about subsampling. And so this is a pretty common process in laser scan data. We have far too many points and we probably don't need all of them. So there are a couple different ways that you can do subsampling. It all kind of depends on what your preference is. And so each of these methods is explained in the exercise. So you might want to try each of these options. Before you do that, make sure you go to your cloud and hit the duplicate button, which is the clone button here, or it's also under edit as well. So just make sure you have a couple of clones before you start subsampling things, otherwise you won't be able to see the difference between the 2 subsampled or 3 subsampled point clouds. But so if we were to go to the wee hint box, you'll see that because in Rachel Opitz's metadata report, she reported that 0.025 space between each point was still quite accurate, and we saw the results of that in the like the screenshots that she provided. We'll go ahead and use that, and then wait for the resampling to finish. So now you can see we have our subsampled cloud. You can see that it's automatically named it here and made it the visible point cloud. And so it looks still quite similar. You can see the outlines of the stones and everything. But you can see that when we go to the points again in the properties window, we now have fewer than 2 million points. So you may need a smaller point cloud than that, depending on the equipment you're working with in terms of computer and hardware. But That's how you get to a subsampled point cloud in CloudCompare. And so now you are ready to actually start cleaning the point cloud, because if you've noticed, there are things like trees and grass that you may not want to appear in the actual reconstruction. And so the next few steps will go through how to remove these bits with essentially a machine learning algorithm called Canoe that comes built into CloudCompare. So this is essentially step 3 of section C of exercise 1. And so what we're going to do is we're going to define a machine learning data set so that Canoe can identify grass, trees. It'll identify the difference essentially between vegetation and stone, the stone which we want to keep. So the first step is to again duplicate your data set just so that you have a intact backup of your subsampled data set. And so this will be our Canoe cloud. And so the way you rename layers is by double clicking on the layer you want to rename and giving it a new title. So essentially what you want to do is you want to identify basically a good example of grass for Canoe to extrapolate from. So you'll need a couple of different samples. As you kind of left click and hold and drag with your mouse, you will see certain clumps of grass, and hopefully the discussion in the exercise explains how you actually how it differentiates between grass and stone. And so to find some of these examples, what you'll want to do is basically how we subsectioned the this from the large slice itself. And again, we're going to use the segment tool. So first, find a good dense patch of grass. Obviously it gets a bit difficult when you're working with a sparser point cloud than we originally started with. Just to remind you, that was the original density of the point cloud. Now we're left with this. So you can, if you have this still in the CloudCompare bin file, you can still use this a bit. As long as you have this selected, it should just kind of segment out of that instead. And so as you can see, we do have a good clump of grass here, but we might also want to remove some of the ground surface surrounding it. Otherwise it might get confused. Might mistake some stone with a similar sort of geometric form there. So you can still use the segment tool again to identify what isn't grass. And you can actually merge this back with your original point cloud with this button here, this merge multiple clouds button. And we don't really care about the original cloud index. Basically it would color that little bit of ground and the main point cloud with different colors, so we don't really want that. What we do want is, so we have our point cloud here, and we have the tiny tuft of grass that we've sort of segmented out. And so we'll call this grass 1, just so we keep track of that. And then we continue on. So that's one way to go about this. The other way is described here in exercise 1 part C. And so this involves using roughness. And so how you get there is you go to, well, first make sure that you have your bigger point cloud highlighted before you do this. And so you go into Tools, Other, and Compute Geometric Features. And so this takes a bit of trial and error as well, but essentially you want roughness calculated, and it sort of depends on the scale of your data set. So if we zoom in to this patch of grass, it could be that 0.65 is going to be enough to sort of differentiate between stone and grass. So we'll try that first. Try 0.8. And so it'll take to compute roughness for the point cloud. So as you can see, using roughness has helped differentiate between grass and the other sorts of features a bit easier. Now that it is a different color, you can sort of separate this out more readily. So essentially that's what you keep doing until you have a good number of samples for Canoe. So I'll just create a few more here. And of course you want to repeat these steps with examples of stone. And so you might want to get a range of examples here. So we might get some from the top of the wall here. As always, make sure you have the main point cloud highlighted. And so once you have a good number of samples here, what you want to do is you'll want to create essentially a stone point cloud. So essentially holding down Control while left clicking on each layer and then clicking Merge Multiple Clouds. We don't really care about that. Just make sure you call it stone samples. And the same again for grass. And so now you're ready to create a Canoe classifier. So they will take these samples from the stone features that you've highlighted and the grass features that you've highlighted. So it's under Plugins, Canoe, and we'll want to train our classifier first. So you can see all the information there. And so what you'll want to have is you'll want to have your stone samples and your grass samples as different classes. And so it will take your samples and identify what it thinks are stone and what it thinks are grass based on what you've fed into it. And so here it has some max core points. So depending on how many points are actually in the samples you've given it, it'll look, if you have less than 30,000, it'll look at all of the points essentially. And you'll want somewhere between 10 and 30,000. So that is fine for us here, and now we'll hit OK. And so this is how it's sort of calculated the difference between your stone samples and your grass samples. Obviously we're going to expect some overlap because if you have like a little bit of ground between like different tufts of grass, that might actually kind of feed into the similarity in here. Stone obviously has some similarities, but this is basically the division that it sees. You can manually edit the boundary if you think it's wrong, so you can sort of pull this over here, you can add a vertex on there and make it so that it incorporates more of this, but basically it should be pretty accurate, and you can reset the boundary to what the statistics have defined it as if you like. So you can give that a go, hit save, and then go done here, and so you can essentially save your classifiers. Give it a name, it'll save it as a PRM file, and then we'll be on to the classification step. So you'll want to go back to your original backup point cloud that you made, the subsampled one, and now we're going to try classifying it. And so same drop down plugin, Canoe Classify. Navigate to your PRM file that you just created, and you'll want to use your selected cloud. Make sure it's selected over there, and then you just want to hit OK. Now this will take some processing power. It might be that your computer will not work with this, and so there will probably be times as your computer processes the data set that the pop-up box actually disappears, a little progress bar. But once you get to this point where it has created a new scalar field based on its definition of grass and stone, that's when you know it is finished. Also, it has this little pop-up here. So you can see it did an okay job getting some of the grass identified, but it's not near what we expect out of it. It did also correctly identify the tree as vegetation. So you can go back and delete the points that it has correctly identified as vegetation if you like. And so the way you do this is by going to Edit, Scalar Fields, and Filter by Value. And you can split between 1 and 2. And so then you'll see that this has your the grass layer here, and this is the stone layer without that bit of grass, but obviously there's still vegetation here. So you can either repeat the Canoe process, creating new classifiers, or you can use the roughness measure again and see how that goes. So 0.8 was okay last time, but we'll try this 0.06 and see what happens here. So obviously this is too small because it's actually splitting rocks and things here. So we'll try again. And so you can see we're getting a little closer, although it wants to remove the top layer of stone off of the wall, which we don't necessarily want to do. So we can try it again. And so it could be that you need to add some smaller tufts of grass to your Canoe classifier for your grass, or something of that nature. Obviously, if we go with roughness at this level, we're going to lose quite a bit of that wall there. So it's just a matter of trial and error to get your data set looking clean. It can be a long process. And as you can see, there's the all the different scalar fields we've created before are all still here on the same point cloud. So if you wanted to test out a couple more of these, you can do, or you can try a couple other geometric features. So it could be that surface variation you think could work here, maybe verticality, although if the walls are quite tall it might catch the edge of the wall as well. But you can try all these at some different radiuses and see what works. All of them will appear in your scalar field in the properties here. And so as you can see, it defaults to the verticality one here. So unfortunately the wall gets in the way a bit here. There's surface variation, which that might work for removing some of the grass there. Or roughness might also work again at that smaller radius. So it's all a matter of preference and what your computer can handle and how far you want to go with this. So as you can see, I have now added more samples to my Canoe grass and stone samples, some smaller grass patches, some more varied stone patches, and so we'll see how this goes. So at a certain point, you might find that you think that's about as good as the Canoe plugin is going to do. And so again, we will split these. So this is after 4 tries, after adding things. So again, we'll go into scalar fields, filter by value. We'll just do 1.1 just to be sure that they are separated. And so those are the bits of grass that the Canoe plugin has removed. And obviously there's still a decent amount that could do with removal. Some bits you can remove just by using the segment tool, but we'll calculate roughness on this and see how we go. And so now that that's done processing, you can see verticality, not the most useful in this case for what we want it to do. Surface variation we might be able to work with, so we'll drag this circle across. Okay, so we could remove some of it here, although it's still getting a bit of the wall. Maybe not. And then we'll also try roughness again. So try the other way actually. So somewhere around this value, if we can make sure we aren't taking too much of the wall off, although technically that wall was built during the excavations, at least that top layer. If you had a look at the report. So if we split it about here, we'll get everything that's gone gray out of the point cloud. So again, scalar field, filter by value, split. And so that would be what it's removed with those parameters, and this is what's left. And so obviously there's still a bit to remove, but that is much better than it was. But the rest of this should be pretty easy to remove using the segment tool. So after you've established your Canoe classifier and you've worked out a workflow to remove the vegetation from your laser scan data, you can repeat the process on the other segments of the Malthi settlement dataset. It might be that the Canoe classifier doesn't necessarily work on all examples on your data set. If you think of what this one looked like from the beginning, it had a couple trees, it has a lot of wall here, quite a bit of grass that's kind of intermingled with a lot of stone. So it could be that by creating the classifier from this data set, there might be a data set that is not a whole lot of grass, and it might be more wall than anything else, especially in the denser part of the settlement in the center. And so it can be that the Canoe classifier misidentifies some sections, which there's an example in the exercise just after this part. And so there are ways to get around that using the segment tool and the merge clouds. So it may take a couple of tries between Canoe and Roughness, although Canoe, once you've used it once and split things, then there's kind of a diminishing returns after a certain point. But you can continue using the Roughness value. So obviously here I've done 0.2, which seems to be working rather well, and we'll see how it looks after this one here. So here it's removed this amount of extra stuff, and so we can kind of see that there isn't too much grass left. There seems to be a bit here, which is a little difficult to tease out anyway, but areas around here are looking a bit better. So so this would be what I would go with here to move on. Still have enough detail to see where the stones are on the surface are located, and not too much grass interfering anymore. And so this will be the one we go with. So if we think about these slices we were talking about earlier, you're going to want to think about how you can keep track and like label each of these slices in a sensible way. So since we're at slice 1 and I've sliced this into 3 pieces, I might, or well, it might end up being 4 up here, but I may end up labeling these A1, A2, A3, maybe A4. And so this one I might end up calling A2 preemptively. Obviously it's having a hard time rendering all that, but so this is what we will proceed with to create a mesh. So now that we've removed vegetation, there will be bits of noise that we'll want to remove as well. So this isn't really anything physically there on site during the scan, but it's more sort of stray points that are created during the process. So to do this, you'll go to Tools, Clean, and so there are 2 filters here. And so for the SOR, it'll obviously look for statistical outliers. So things are basically quite far away from the rest. And so you can try a couple different ways of using the filter. I'm going to go with these settings as hidden in the hint box on the exercise. And so you can see that's done quite a number over here a bit. Depends how happy you are that the geometry of the stones over here are still intact. Looks okay to me, really. But it depends if you're okay with that or not. You can always go back and have a look. So if you aren't happy with that, you can go for some less drastic cleaning. So obviously if you use more points for mean distance estimation or a larger standard deviation, then it'll get rid of less points, really. So that's not quite as bad. But try a couple different settings and see what appeals to you. So once you're happy with your clean data set, you can also remove anything that you don't plan on using in the model. So obviously we're not going to be using this kind of open space over here. So you can slice that off and get rid of that. Okay, so here we have our clean, usable bit of point cloud here. And so we have to calculate normals so that we can have it calculate the mesh properly. And so there are many options here, but you can do a dive into CloudCompare's documentation, but Quadric is supposed to be good for curvy surfaces, which is what we have here. You can hit auto and it'll calculate the best radius based on nearest neighbors for your data set. And then we'll want to use preferred orientation plus set. And so then we'll hit OK and let it process. Okay, so that was pretty quick. And so here you can see we have our normals. And so the reason we need normals is that they indicate the directional trend of your data. So that's quite important when you're trying to build a mesh. Where do the triangles go, basically? And this is how the software calculates that. So always make sure to save. And when you save, make sure that if you want to save all of these layers, that you need to highlight all of those, actually. And so once you have your normals calculated, you can then create the mesh by going through plugins to this option here. And so basically the way you decide on what to set the octree depth to, so the higher the number, essentially, the more detail will be preserved when creating the mesh. And so there's a limit to this in terms of computer processing ability and the stability of the software itself. If you go up to 24, it will crash. So if we go to 11 or so, you could probably get away with 10 or maybe even 12. But at a certain point, there's diminishing returns. So 11 is a good setting. Make sure that the output density as SF is enabled. And when you get over to advanced, make sure that samples per node is set to 1 and linear weight to 1. And then once you're happy with that, you can try with other settings as well, but here we are. Hit OK and let it process. And so when the mesh is finished, you'll want to turn off the point cloud, which will still be on. And so this is your mesh. So you can see where there's still a few areas where the grass is still visible, but that will get fixed in some additional processing in exercise 3. But you can see it's also added quite a bit of mesh off to the sides here. So to remove that, we'll go back to our display ranges down here and bring it in this white dot from the left all the way over, because keep in mind that if you want to complete the entire laser scan data set, you don't want too much overlap between segments of your map. So That looks good to me. There will be a few holes to fill later on, but that's all part of the post-processing. And so again, we'll go in to our edit scalar fields, filter by value. It'll copy that range and you can hit split. And so that is our mesh for this section here for A2. So that is the one we want to keep. Here we are. And so at this point you'll want to save your bin file. However much of this you want to keep is up to you. It's mostly so you can retrace your steps if need be. But when you want to export, you'll just hit the save button, change this to obj mesh, and give it a sensible name. And then that will save your mesh. So make sure to follow the rest of the exercise 1C to finish everything up, but otherwise the meshes will then be ready for later processing, cleaning, and hole filling in exercise 3. Exercise 2 doesn't require too much technical navigation, so the next video will be about normal mapping in exercise 3. So see you then.